In this video, we're going to continue our discussion about making the transition from basic math to algebra. And we're going to focus more on well, the second component. We talked in earlier videos about how in basic math you learn how to add, subtract, multiply, and divide real numbers. And the assumption is, if you're very good basic math students, then you can do this, do these operations, perform these operations on all the real numbers. And real numbers are often depicted with a number line. That is to say, any number that can be represented on a number line is considered a real number. And so these real numbers could be 0, integers, of course, and they can also be fractions, decimals, and percents. We had a brief discussion about those guys, 1.5. But at any rate, real numbers, any number that you work with, most numbers, unless you could be an accelerated student in elementary school, but for the most part, all of the numbers that you've worked with in elementary, your basic mathematics, are real numbers. Now the real numbers consist of two classes of numbers in terms of which numbers are real and not real, and some of them, the two sets, if you will, subsets of real numbers would be your rational numbers and your irrational numbers. And we spoke a little bit about those in a previous video. We won't get too far into it today, because we're going to go ahead and move on to another aspect of making the transition from basic math to algebra. But as we said before, whenever we say ratio, rational, ratio, think ratio, A over B. If you can make it into a fraction, it's rational. If it's not rational, irrational, prefix meaning not, so it cannot be made into a fraction. And again, so not a fraction. And for the most part, and let's just talk about the irrational ones. They're hard to represent to some, because if it's not a fraction, then the question becomes then what is it? But again, we talked about pi being a popular irrational number. It's never-ending, non-repeating, goes on indefinitely, and maybe we should perhaps we will in fact devote a video to this. Sets of numbers. You have E, which is also a popular number, not a letter, a number. And then as far as representing irrational numbers in a decimal form, that's a little tricky, but for the most part, it's kind of agreed that a pattern such as this would perform that operation. And notice that in writing this decimal, we started out with 2 ones and then 3 ones and so forth on. But we're getting a little off topic at this point, because in this video, what we want to do is talk about the fact that having mastered all of these real numbers, adding, multiplying, subtracting, and dividing, as we said before, the teacher in grade school could give you some problems. Let's just say that you're doing sums, okay? And the teacher would have to give you a bunch of problems, not a bunch, but a list of problems, and this is where you practice your skills, and you got very, very good at doing at adding, if you will. And this could go on indefinitely. But here's what we want you to recognize: in algebra, we don't want to do this. We're assuming that you know how to do these things very well, but we now want you to start to focus on the concept, and we'll do this as the second aspect of our continuing series here, is that rather than giving you individual specific problems, we're going to just give you an expression. And first of all, let's say why this is called an expression. Again, we know that the x and the y are variables. So x and y are variables. Those are two variables. And again, we want this, as we say, math is a language. We wanted to, don't want to insult you, but we want you to realize that there's, a method to the madness. Why they call variables? Because they vary. All right, and what that means to us, that they can take on various values of all of the real numbers. Okay, so if with this expression, given this expression, you can now assign x certain values. Let's say that you want x to be 1/2, or what's got 3/5, something else, and it doesn't have to make a lot of sense. And y could be 8%. Now, because you're a very good basic math student, we would expect you not to be bothered by this. You may say that's an odd thing to be given, but having said that, we would still expect you as a basic math student to be able to handle this, to do this. So, and we would doubt that there's any top-notch basic math student who has, if you claim mastery of your basic math skills, if you've claimed mastery, then this would not be a challenge to you. So, given that expression, x plus y, and when you have an expression, there's a couple of things you can do, and one thing you certainly cannot do with it. The one thing that you can do is you can substitute these values. So x is 3/5. Okay, so we'll put our 3/5 there for x. Our plus sign, the operation is clear. We're going to add that 3/5 to our y value of 8%. And you say, why would I want to do that? You have one number in the form of a fraction, the other is in the form of a percent. But again, we repeat, these numbers can be presented in many forms, but you need to now convert them to a form that you can work with. And more often than not, and it doesn't really matter as long as you put them in the same form. But in this case, let's keep it simple. We're going to change them both to decimal. So in this case, we're going to take that 3/5, divide bottom and the top. I'm not going to do it. We're not going to do it in this video, but we would expect you to know that that's a 0.6. Okay. Plus, we're going to take that 8% and change it to a decimal, two places to the left. We'll do that in future videos. This will become a 0.08. And then you perform your sum and add these guys together, so you get a total of 0.68. Alright. So, here's what you can do with an expression. You can certainly substitute, and you can simplify it. So what you can do is you can substitute in the values, and you can simplify. So this is called simplifying the expression. But what you cannot do with an expression, and we'll talk more about this in the next video, you cannot solve it. And when we say solve in algebra, that takes on a whole different meaning. So if you have an expression, you can simplify the expression. We expect you to be able to simplify the expression, but in this case, we cannot solve it. And we will understand in our next and future videos why you cannot solve it. Okay? That's it for now. We'll continue this discussion in future videos. Take care. See you next video.